In section 7.2, we're going to be talking about rational exponents. That's just simply when you have a fraction as an exponent. Okay, we can rewrite these, given this definition above, a number to a fractional exponent with 1 as the numerator and n as the denominator can be rewritten as this radicand, which we learned to evaluate in the last section. So basically, one of the most important things to remember is that your numerator, your denominator becomes the index when you rewrite it. Okay, so that's what the biggest thing, if you can remember, your denominator becomes the index. So when I rewrite number 1, I have 49. I'm going to rewrite it as a radical. My denominator becomes my index, which is a known. Okay, and my numerator is just a 1. So square root of 49 means what square gives me 49? And that's an easy one, so we'll do 7. Number 2, I want to rewrite this as a radical. That becomes 27 because my denominator is a 3, my index is a 3. So this time I want to know what cubed gives me 27. And that answer is going to be 3. We still evaluate these the same as we did in section 7.1. So if it's been a while since you've checked that one out, go back and look through it. Number 3. Now, this 2 is kind of sitting out front. This is m to the 1/3, so my 2 I'm going to leave out front, and I'm going to rewrite my m, and my denominator is a 3, so that means my index is a 3. And I can't simplify that. There's nothing more I can do, so this is just my solution. Number 4, when this is in a parenthesis, it means this whole parenthesis is raised to the 1/3 power. That means when I write my radical, I put everything that was in the parenthesis. And my denominator is a 3, so my index is a 3. Now I want you to take a moment and look at the primary difference between number 3 and number 4. If you notice, number 4 has a parenthesis around it. That means if there's a parenthesis around it, all of that value is under the radical. If it is not in a parenthesis, then the 2 just stays in the front. Okay, so take special note between the difference between 3 and 4. Alright, moving on, number 5. Since that's a parenthesis, that means that whole value in the parenthesis is going to be under the radical, and then my denominator is a 2, so my index is 2. So I want to know what squared gives me 9x to the 4th. Well, that's going to be 3 and an x squared. Number 6, this negative is sitting out front because there's no parentheses, so it's just out front, so I need to put 64 under the radical and take the square root of that. My negative stays in front, so square root of 64 is 8, and my negative is just sitting out front, so I'll bring it down, and that's my solution. Okay, now we're going to look at when our numerator is not a 1. All of our previous one, there was a 1 right there, and a 1 there, 1 there, and right now we have values in places of our numerator, so we have 2 different forms we can use. We can use this form, and we can use this form. They're both correct, however, this form is usually the easiest to be able to solve from. So most often I will usually transfer it into this format, but either one will work and both are correct. It's kind of like a preference. So if I have 4, and since a fractional exponent, remember my denominator is my index, and then I simply put that whole thing in a parenthesis and raise it to the 5th power. Raise it to the numerator's power. Okay, now I'm going to evaluate the inside first. What is the square root of 4? What square gives me 4? So it's 2. And then I put my parentheses back around it and evaluate 2 to the 5th power. Now remember, that means 2 times 2 times 2 times 2 times 2, which is going to be 32. Okay. Number 8, since that negative is in a parenthesis, I include it under as my radicand. My denominator is my index, and then afterwards I put the whole thing in parentheses and raise it to the numerator. Alright, we always start on the inside and evaluate this first. What cubed gives me negative 8? Negative 2. Then don't forget to bring down your exponent, and then now I evaluate negative 2 times negative 2 times negative 2 times negative 2 is going to equal 16. Number 9, since that's in a parenthesis, that whole value goes underneath. My denominator is a 5, so that's what my index becomes, and I raise it to the third power. Okay, and there's nothing, I can't evaluate that. Nothing to the fifth power gives me a 2x. So since this can't be simplified, I can't cube it either. I can just leave it. So on this one I'm going to leave it. I'm going to also write it in the other value. Remember, we've been putting it into this form so we can evaluate it. Well, since this one doesn't go any further, just for some practice, I'm going to put it in this form as well so you can see that. And that's just going to be 2x to the third power and then the fifth root of that. Okay, either one of those are correct, but I just wanted to use one of them to show you both forms. Alright, number 10, we're going to have 16 ninths, square root of that, and then I'm going to cube it. Alright, so I want to know what squared gives me 16 ninths. Well, 4 squared gives me 16. 3 squared gives me 9, so that's going to be that. And then I need to bring down, remember to bring down, raise it to the third power. And I treat these as 4 to the third power. That's 4 times 4 times 4 is 64. And then 3 raised to the third power is 3 times 3 times 3, which is 27. Okay, and our helpful hint down here is we said most of the time this second format is easier to calculate. Okay, so that's why for all the ones we had calculations, we used that format, and for the one we couldn't make a calculation, I showed you the other format. Okay, it's two formats. One's just easier to calculate.